Alright, so apparently my video for 10.5 disappeared, which annoys me greatly. This is all about parametric surfaces. So recently we've done some parametric equations that give us a space curve. That is, x was a function of t, y was a function of t, and z was a function of t. And that's all fine and good. However, what you're going to see is that when t is something, x will be a number, y will be a number, and z will be a number, period. That's it. That's all. Don't want to talk about it anymore. Okay? So when you trace these out, you will only get, you see a space curve. Parametric surface is similar, except that instead of having one parameter like t, it's going to have multiple parameters. Now, one of the easiest ones to think about is to think about it in terms of understanding a concept. So oftentimes in our daily life, you'll have things that are functions of something else entirely. So for instance, we can do this a couple of ways. We could say the surface area of a cylinder is a function of radius and height. Okay, something like that. And you could say, well, you could think of it in that terms. You've had, in other words, you've had situations where one thing's a function of something else. This is not what we're talking about. What we're talking about instead is things like this. I have, stress in my life. Okay, but I have maybe work stress, and I have home stress, let's say. And yeah, I guess that's all. Now, what affects those? Well, oftentimes they affect one another, but let's just pretend like they're separate things now. If this is, if you will, I'm just going to call this y1, if you will. I'll call this guy here y2. I can call him whatever I want to call him. Okay, but for right now, each of them is going to be functions of other things. So oftentimes stress at work has to do with, I don't know, rather it's a function of, I don't know, sleep. Sleep is a big one. Number of idiot interactions. And I'm not talking about with kids. Okay. My home stress is often affected by the exact same stressors. Not always. Sometimes it's more. Oh, wait. Work stress affected by, let's see, wife interaction. Sure. Now, you're like, wait, is it really? Is your work stress affected by that? Not really, because watch. My sleep, as the sleep goes up, my stress goes down, you see. So it might be something like -4 times sleep. So for every hour of sleep I get, perhaps my stress at work goes down by 4 points, whatever that means. Plus, number of idiot interactions. Well, as the number of idiot interactions goes up, my stress goes up as well, yes? We'll call them IIs. And my wife doesn't really affect my work stress, so it might be 0W. That make sense? And home stress, this is work. Home stress might very well be affected by sleep. And again, something like this. Idiot interactions. Yeah, I don't really think idiot interactions affect my home life that much, but wife interactions do. And so if these are good interactions, then my stress goes down. If they're bad, they go up. So we'll assume that these are bad interactions. We have to assume one or the other, otherwise it's going to be weird. So as bad interactions goes up, my stress goes up too. So this maybe goes up 16 for every bad wife interaction. Are you with me? In other words, positive because the stress is going up. If it were good interactions, of course, it would go down. Okay, this is what we're talking about. Each of these quote-unquote y values over here are affected by other quote-unquote x values. Does that make sense? And so when we think about these things, I want you to kind of visualize that in your head. If you can, it really makes, I think, the rest of this deal easier. Okay, now, in statistics, that's the idea of breaking down those values. Like, where did that negative 11 come from and all that? Well, we did some statistics on it. Excuse me. And, that's where we come with those numbers from. Those ones there I just made up, of course. But that's how you would do that in the real world. Now, here's a couple examples right out of the book here. You might have something like this. By the way, books always use U and V. That's just how it runs. So R is a function of U and V. R is a vector. So my X is decided by this guy right here. I'm just going to write 2 sine U. And Y is 3 cosine U. And Z is just V. Okay. Notice that V does not affect X and Y, yes? X and Y is doing their thing, and V is just going to, and Z is just going to keep getting bigger. Okay, so if you were to graph this guy, it'd be kind of interesting to see what it looks like. So that's what I'm going to do. I'm going to grab the old 3D calc plotter, get rid of this, and I'm going to grab a parametric surface. There you go. And I'm going to type in the function in question. Now, I don't need you to print these out, and I don't need you to draw them. I just want you to look at them for this section and be comfortable with what they do. I prefer that you actually try to graph them on this deal. But aside from that, I don't want you trying to spend hours trying to draw these things out. No, it was 2 sine U, wasn't it? Was it 3? Yeah, 3 cosine. Boom. Oh, wow. Now check it out. U only went from 0 to 2 pi. If you think about that. That's cool. That's plenty. And then V went from 0 to pi. That's why there's no negative Z values, because the Z is V and they just went up. Dude, look at that. We would call this, by the way, an elliptical cylinder, huh? What do you think about that? It's elliptical because of the first two, and it's a cylinder because the Z just goes up. Okay? You're going to be looking at some of these guys, trying to make a little heads or tails, I think, out of what they are. Kind of seeing if you if you understand what they're going to look like once you get going. Now, let's try this next one here and see what you think about it. It's a little harder, perhaps. So R of U and V. Okay. Now, if you were a betting man or a lady, what is your X doing? Your X is just being this nice linear looking thing. It would be three-dimensional if you were just to graph, Z equals X plus Y or something. That's what it would look like. It's very linear. This also will be linear. This, however, will be quadratic. Okay, so pay attention to that when we graph this guy. Now, same thing goes here as we just did a minute ago. And it is, I changed my mind. Delete. It's U plus V. By the way, this computer program only accepts U and V's, as you can see. Oh, it's 2U plus 1 and 1 minus U squared. Now, before I hit enter, let's think about this for a minute. Look at what's going on with my U's. My Z's, rather. My Z's, they're going to get bigger and bigger and bigger negative the further you go out. They're going to be 1 at 0. So I'm going to see a quadratic look to my Z values. And my x's and y's are just going to keep going out and out and out. That's not going to be a problem at all. Now, in this particular problem, they said, let's let the u go from -1 to 1. And same thing with v. Hit enter. Bam. Well, what do you know? My z's are quadratic. If I let my z's go out further, check it out, I would get a, whoa, it's like a trough, man. It is like a trough, dude. It's exactly right. It's pretty exciting. Okay, and then you can make your x's and y's go out further too. And you just see it's a bigger and bigger and bigger trough. And the further out you go, of course, the more pixelated it gets. It's only graphing by number of steps 15. It's going to be very pixelated in that case. But again, all I want you doing today on these guys is thinking about, first of all, we have many things in our lives that are affected by the same two things. So in this case, back over here, again, it's hard to tell what you're talking about. It doesn't matter, Jay. Look, x is affected by u and v. Y is affected by u only. And z is also affected by u only. But notice this one is affected linearly by u. This one's affected negative quadratically by u. Again, in statistics, that's something that comes up over and over and over again, is what is the relationship between these variables? Okay. Now, I'm going to make one up here real quick, and we'll see if we can figure out what she's going to look like. Now, by the way, these can be written in several ways. As you saw, I can write them like so. I could write them as x equals, y equals, z equals, because that's how the computer gets them. Or I could write them as something I plus something j plus something k. Totally makes no difference to me how they're done. I'm going to do 1 minus absolute value of u cosine of v. And I'm going to do 1 minus absolute value of u sine of v. Okay. And then I'm going to do sine squared of, is that sine squared or sine cubed? Oh no, I'm sorry, this is z equals u. Alright. So let's think about this for a minute. Okay, first of all, in the z direction, z is just linear. We're just changing out z's. We're just going to call them u's now. Doesn't change anything. So when I first look at this, I think, all right, cosine and sine. So I'm thinking it's going to be cylindrical, all right, circular, and then this is going to give me height. So it's going to be like this, and then it's going to go up. That's cool. Should have been a u. Should have been a u right there, friends. So what I want to think about is this: my amplitude is going to be the same for both of them. I feel like it's going to be circular, but it might be kind of a weird circular pattern. In fact, I feel like there's going to be times when you're going to have 0, right? For instance, on this deal here, if u is positive or negative 1, okay, then this is going to become 0, and so that's handy. X is also going to be 0 whenever cosine is 0, so that's kind of cool. So we're going to have like repeated zeros on the x-axis. We're going to have repeated zeros on the y-axis as well, of course. Whenever v is 0, or whenever v is 0, this is going to be 0, and then over at pi and 2 pi and so forth, this one's going to be 0 at 90 and 3 pi over 2 and so forth. This guy here is only going to be 0 again at the two places when u is that and when u is positive or negative 1. Please understand that we only graph on the x, y, and z planes, right? Right? We only graph on the x, y, and z locations. There's no t, there's no u, there's no v. None of that gets graphed. So just be aware of that. Okay? So let's go look at the graph of this guy and just see what's what. So let's clear this mess. Alright, give me a parametric, actually refresh it first. Parametric surface. parentheses 1 minus abs u times cosine v. I'm not going to lazy, so I'm just going to copy that and change the other thing to sine because, well, I don't want to type it again. And this fella's just u down here. No, weird. Cool. Let's go negative 2 pi. Positive 2 pi. Oh, right on. Oh, that's hot. That's awesome, dude. Check it out, yo. Look at this. Around the x, this is the x-axis right now, pointing up in the air, right there. Around that, there's going to be infinitely many places where there's going to be a bunch of places, I should say, where the x and your y's are equal to 0, yes? And so, just be aware of that. So, when you're on this plane across here, just be that there's a bunch of places what happens, obviously here and here as well, it's equal to 0 and 0. Let's put this to the z's up just for fun, shall we? Stop. Everywhere around this middle seam here, the z is equal to 0, right? So that's easy to know. Up here and down here is one of these places we talked about previously. Okay, right here in the front of this guy, right here in the very front of it, it looks like my y is equal to 0. On the very back, y would also equal 0. So check that out. I could go out some further and give me some more. Let's see if I can get it to repeat itself further out, see what happens. Apparently nothing happens that much further out. So interesting. Maybe if I change this axis, maybe here we go. And there you go. Okay. So apparently all it does is keep getting fatter and fatter and fatter as time goes on. Do the x's and y's still equal 0? Sure they do. Anytime you're looking at the side of it over here, anywhere where you're on the y-axis, so like right there, for instance, and way over here, for instance, you have anywhere along that line, as a matter of fact, you're going to have an x that's equal to 0, correct? So it's pretty easy to do. Again, the point of this is to understand the concept that many things in our lives are functions of other variables. And again, for instance, work stress and home stress might have to share some of the same stressors. And so because of that, we just know that. Maybe another one that might come to mind is my blood pressure. And my blood pressure might be affected by a variety of things. For instance, it could be affected by stress, sleep, and by the way, it doesn't have to be just U. You're thinking, no, it's U and that's V. That's right. It could also be W. So like blood pressure, stress, sleep, diet, whatever. My weight could be affected by stress, sleep, and diet. That's true. Oh, my interpersonal relationship could also be affected by stress, sleep, and diet. By the way, some of these are like giant, huge things, like blood pressure. Well, my stress really affects this thing. It does for me. It doesn't for everybody, but it does for me. So as my stress goes up, my blood pressure goes up. I'm not going to say it goes up like a quadratic fashion. It may not be like 1. It might not be like 10 stress squared, but it's pretty good sized, and it's definitely positive. As my sleep goes up, my blood pressure comes down. That is 100% true. This is going to be negative. Okay. The diet, as my diet gets, I don't know, more protein, I just made that up, my blood pressure comes down. Okay, so obviously that would be a negative relationship. Stress, all three of these things, stress, as my stress goes up, my weight goes up. As my sleep goes up, my weight doesn't really change at all. As my diet, again, if I eat more, let's say more protein, in theory my weight should come down. I don't know, it doesn't seem to affect it much. My interpersonal relationships are not affected by my diet at all. They are affected by my sleep. If I don't get any sleep, I'm kind of mean. And my stress, it does affect my interpersonal relationships because I'm mean about that. Okay, that's more what I want from this section than anything else, except I also want you to graph it. I do not want you to try to draw them. If you want to print them off and like glue them on, that's fine, whatever. It's not necessary, but I want you feeling comfortable with it, because this section is all about visualizing. And then, of course, when you get into a statistics class later on, and you're fitting curves, this is the kind of the idea behind it there. So just be aware of that. All right, that's enough yabbering.